Good morning. So welcome to all. So myself Dr. Mahesh, so Department of Chemistry, Vardhaman College of Engineering. So today I would like to explain the estimation of amount of ferrous ion in given solution by dichrometry. So in this experiment, so the main objective is to estimate the amount of ferrous ion present in given solution, so by using the potassium dichromate. So these are the main objective for this experiment. So operators required. So we require the conical flask, standard volumetric flask, and beakers, burette, and finally so pipettes. So these operators are required for this experiment. So chemicals requires. So we requires the potassium permanganate. So the formula of potassium permanganate is K2Cr2O7. So we should take the 0.1 normality of potassium permanganate, and so we require the sulfuric acid. So the formula of sulfuric acid H2SO4, and we require the syrupy phosphoric acid. So the formula is H3PO4, and we require the diphenyl amine. So it is act as a indicator. This is the indicator. So we require the more salt. So these chemicals are required for this experiment. Okay, students. So next we go for the principle. So here, ferrous ion is oxidized to ferric ion by potassium dichromate in acidic solution. So unlike potassium permanganate. So why? Because this potassium dichromate is a primary standard solution. So what is the meaning of primary standard solution and what is the meaning of secondary standard solution means? So first of all, we discussing the primary standard solution. The primary standard solution, which can define as the substances which is available in the pure form. So that's we are called as a primary substances. So what is the example of primary substances? Potassium dichromate K2Cr2O7. And secondary substances means the substances which is not available in the pure form. The substances which is not available in the pure form. So that is the secondary substances. So what is the example of secondary substances? Potassium permanganate. So potassium KMnO4, potassium permanganate. So it is the secondary standard solution. So okay, students. So next, it can be used as a primary standard solution. So primary standard solution means the substances which is available in the pure form. So the external indicators like diphenyl amine. So in this experiment, we have to require the one indicator. So that is the diphenyl amine, unlike potassium permanganate. So the solution appears green pigment. So whenever we are starting the titration, so what happens? So the colorless solution, the colorless more salt solution titrate against with the potassium dichromate. So initially we are observing the green color pigment. So this green color pigment indicate the formation of chromic ions. So chromic ions, which is formed in the solution. So that the green color pigment indicate. And after the end point, we have to observe the violet blue color. So at the end point, we have to observe the violet blue color. So this is the experiment. So first we are taking the colorless solution, colorless more salt solution. So this colorless more salt solution, we should add the mixture of acids. So that is the sulfuric acid and phosphoric acid, and we should add the indicator, 1 to 2 drops of the indicator. So this colorless solution titrate against with the potassium dichromate which is present in the burette. So whenever we are observing the violet blue color, we stop the titration and we note down the burette reading. So the violet blue color indicate, it can form the diphenyl benzidine. So this is the compound of potassium dichromate. So potassium dichromate. So this is the potassium dichromate solution, K2Cr2O7 solution. So standard solution of potassium dichromate. So at the end point, we are observing the violet blue color. Okay students, so initially the colorless solution titrate against with the potassium dichromate solution. So we have to observe the violet blue color. So that violet blue color indicates the end point or neutralization point. So when we are observing the violet blue color, we stop the titration and note down the burette reading. Next procedure. So in this experiment, so first of all, step 1, so we have to prepare the standard solution, standard potassium dichromate solution. So how can we prepare the 0.1 normality of potassium dichromate solution? So we are weighing the 0.49 grams of pure crystalline substances of potassium dichromate. So we are transferring into the 100 ml volumetric flask and so diluted with the distilled water. So make up with the up to the mark. So this concentration, so this content of the flask shaken well and uniformly concentration, and we should get the 0.1 normality of concentration. So this is the procedure. So how we prepare the 0.1 normality of potassium dichromate? So we are weighing 0.49 grams of potassium dichromate compound and transfer into the 100 ml volumetric flask. So dissolved with the distilled water. So up to the mark, and so we can prepare the 0.1 normality of potassium dichromate solution. And second step is the estimation of ferrous ion. So estimation of ferrous ion in more salt solution. So this is the second step. So in this second step, so we are pipette out 10 ml of more salt solution into the conical flask, and we should add the acid mixture. So 2.5 ml of acid mixture, so that are sulfuric acid and phosphoric acid mixture, and we should add the 2 drops of diphenylamine indicator to the more salt solution. So this colorless solution titrate against with the potassium dichromate which is present in the burette. So initially we should get the light green color. So that light green color indicate the formation of chromic ions. At the end point, so we should get the violet blue color. So when we are observing the violet blue color in the conical flask, so that violet blue color indicate end point or neutralization point. So we stop the titration and note down the burette readings. So this is the observation table. So in the first column, so we should take the volume of ferrous ion, so the more salt. So we should take the 10 ml of more salt solution. So initial burette reading, so in general we should take the 0 is the initial reading. So final reading, for example, so we should get the 10 ml. So what is the differences? So 10 minus 0, 10. So repeat the titration until we get the concurrent values. Okay students, so repeat the titration until we get the concurrent values. So we repeat at least 2 times. So in second time also, so we should take the 10 ml of more salt solution into the conical flask, and we should add the 2.5 ml of acid mixture, and we should add the diphenylamine indicator, 2 to 3 drops of diphenylamine indicator. So what is the initial reading? So initial burette reading is in second time, so that is the 10 ml. Why? Because so in the first time, so we are getting the 10 ml. So the for example, we suppose that final reading is 20. So what is the differences? 20 minus 10, 10. So the average volume of potassium dichromate is 10 plus 10 by 2. So that is the 10 ml. 10 ml of potassium dichromate. So required for the neutralization reaction. And we do the calculations. So the more salt versus potassium dichromate. So we have to use the normality principle. So N1 V1 is equal to N2 V2. So here N1 is equal to, so what is the N1? So N1 is equal to, so normality of more salt, and V1 is equal to volume of more salt. So N2 is equal to normality of potassium dichromate. So that is a 0.1 normality. So Vt is equal to volume of potassium dichromate. So that is the burette reading. So N2 is equal to N1 V1 by V2. So N1 is equal to N2 V2 by V1. So we substitute all the values. N2 is equal to normality of potassium dichromate. So that is the 1.1. into, so volume of potassium dichromate. What is the volume of potassium dichromate? 10 ml, be reading. And volume of more salt is 10 ml. So both are get cancelled. So we should get the 0.1 normality. Okay, now, so this is the normality of more salt solution. So that is the 0.1 N. So finally, amount of ferrous ion in given solution, that is equal to normality of more salt into equivalent weight of the ferrous ion. So normality, what is the normality? So 0.1 into, so the equivalent weight of ferrous ion is 56. So that is the, so 5.6, so grams per liter. So the final is, so the amount of ferrous ion present in the given solution, so that is the, so final result is 5.6 grams per liter. So okay students, so we are not just about providing a quality education, so we below the all round developments. Okay students, okay, thank you. Good morning, welcome to all. Myself, Dr. Mahesh, Assistant Professor, Department of Chemistry, so Vardhaman College of Engineering. Today I would like to explain the, so estimation of amount of ferrous ion in given sample solution by dichrometry. I would like to explain the, so estimation of amount of ferrous ion in given sample solution. Objectives. So the main objective is, so determine the normality and strength of given sample solution by using standard solution of potassium dichromate. So operators require, so we require the conical flask, standard volumetric flask, beakers, burette and pipette. So these operators, so we require for this experiment. Chemicals requires, so we requires the 0.1 normality of potassium dichromate solution, so that is the K2Cr2O7, and sulfuric acid, so that is H2SO4, and phosphoric acid H3PO3, and diphenylamine, so it is diphenylamine, it is act as a indicator, and more salt solution. So what is the formula of more salt solution? FeSO4 ammonium sulfate 6 moles of water. So this is the formula of more salt solution. Okay students. So next, principle. So here potassium dichromate. So potassium dichromate react with the more salt solution. So potassium dichromate, it is act as a strong oxidizing agents in the presence of acid mixtures, and more salt, it is act as a redox reducing agents. So the more salt react with the potassium dichromate solution, so it is a redox reaction. So redox reaction means, so in a single chemical reaction, oxidation and reduction takes place. So that's why we are calling the redox reaction. So here ferrous ion is oxidized to ferric ion, so in the presence of potassium dichromate solution. So unlike potassium permanganate, so why? Because, so here potassium dichromate is a primary standard solution. So primary standard solution means the substances which is available in the pure form. So that is the primary standard solution. So what is the secondary standard solution? Secondary standard solution means the substance which is not available in the pure form. Okay, so that is the secondary standard solution. So potassium permanganate is the secondary standard solution. Potassium dichromate is the primary standard solution. Okay students, so potassium dichromate is the primary standard solution. So it can be used as a primary standard solutions. So in this experiment, so we have to use the diphenylamine, it is a indicator. So we have to difficult to observe the sharp color changes, so in the addition of the potassium dichromate. So that's why, so we have to use the indicator. So that indicator is diphenylamine. So initially, the solution appear the green color pigments. So this green color progressively pigments indicate the formation of chromic ions in the solution. So at the end point, so we should get the violet blue color. So here potassium dichromate K2Cr2O7 react with the sulfuric acid, so it can form the K2SO4 plus Cr2SO4 taken 3. So that is a chromic sulfate. So it can form the 4 moles water plus it can form the 3 moles nascent oxygen, and more salt, that is a ferrous sulfate. So 2 moles of ferrous sulfate, so react with the sulfuric acid plus nascent oxygen. So it can form the, so the ferrous ion, it can change to the ferric ion, Fe ferric sulfate plus it can form the water. So here 1 nascent oxygen is there and here 3 nascent oxygen is there. So this whole reaction, so we should multiply with the 3. So we should cancel the both 3 nascent oxygen. So here 3 nascent oxygen, here so 3 into 1 nascent oxygen. So this 3 nascent oxygen both will be get cancelled. Okay students. So now K2Cr2O7 plus so 2 moles of FeSO4 plus here 4 moles of sulfuric acid, here 3 moles of sulfuric acid. So total 7 moles of sulfuric acid. So it can form the K2SO4 plus Cr2SO4 chromic sulfate. So it form ferric sulfate plus it can form the, so here 3 moles of water molecule, here 4 moles, but the total 7 moles of water molecule. So this is the overall net reaction. You have to observe the overall net reaction. Here chromium. So what is the oxygen state of chromium? Plus 6. So plus 6 it can change to the, so plus 3. So here Fe plus 2. So ferrous. So ferrous Fe plus 2 it can change to the plus 3. Okay, sir. The potassium dichromate is act as a strong oxidizing agent. So it oxidizes the ferrous ion. So the ferrous ion it can change to the ferric ion. So here more salt is act as a reducing agent. It can reduce the potassium dichromate. So that is chromium plus 6 it can change to the plus 3. Okay, sir. So this is the overall chemical reaction. So this is the figures, some figures, potassium dichromate solution. Next procedure. So in this procedure, so first step is the, so preparation of standard potassium dichromate solution. So how can we prepare the standard potassium dichromate solution? So we can directly prepare the standard solution by using the normative principle. So why? Because so it is a primary standard solution. So it is easily available in the pure form. So that's why no need to go for titration method. So directly we can prepare the by using normality principle. Okay, students. So first of all, so we are weighing the 0.49 grams of potassium dichromate solution. So we are weighed and transferred into the 100 ml volumetric flask. So dissolved with the distilled water up to the mark and shake vigorously. So we should get the 0.1 normality of concentration. So this is the preparation of standard potassium dichromate solution. And second step. So second step is the, so estimation of amount of, estimation of ferrous ion in given sample solution. So how can we estimate the ferrous ion? So by using the standard solution of potassium dichromate. Okay, students. So we are pipette out 10 ml of more salt solution into the conical flask, and we should add the 2.5 ml of acid mixture. So that is the phosphoric acid and sulfuric acid mixture. We should add the 2.5 ml of acid mixture, and we should add the 2 to 3 drops of the indicator, diphenylamine indicator. So we should get the colorless solution. So this colorless solution, so we are titrate against with the potassium dichromate solution, so which is present in the purate. So this colorless solution, so titrate against the potassium dichromate solution which is present in the purate. So what we have to observe? So when we are observing the violet blue color in the conical flask, so we stop the titration and note on the purate reading. So initially, so we should observe the light green color. So that light green color indicate the, so formation of chromic acid or chromic ions. After completion of the all ions, so the potassium dichromate react with the indicator, so that is diphenylamine. So it can change to the violet blue color. So when we are observing the violet blue color in the conical flask, stop the titration and note down the purate readings. So we should draw the table. So volume of ferrous ion. So in general we are taking the 10 ml of more salt solution into the conical flask. So initial reading. So in generally, so that is a 0 volume. So when we are observing the violet blue color in the conical flask, so that is the end point or neutralization point. So we note down the purate final reading. So for suppose we are getting the 10 ml, at the 10 ml of potassium dichromate solution. So we should get the violet blue color. So that is the burette final reading. So the difference is, so 10 minus 0, 10. So repeat the titration until we get the concrete values. Okay students. So repeat second time. So we are taking the 10 ml of more salt solution in the conical flask. So we should follow the same procedure. So add the acid mixture, 2.5 ml acid mixture, and add the 2 to 3 drops of indicator. So this colorless solution titrate against with the potassium dichromate, which is present in the burette. So when we are observing the violet blue color, so we stop the titration and note down the burette readings. So here initial reading is, so 10 ml. So why? Because so while we are starting the 10 ml. So the final reading, for example, we are getting the 20 ml. So the difference is 10 ml. So the mean value, average value of potassium dichromate burette readings, so 10 by 10 by 2. So we get the 10 ml. So the average value is, so 10 ml. So now, so we can do the calculations. So the more salt versus potassium dichromate. So the principle, normality principle, N1 V1 is equal to N2 V2, N1 V1 is equal to N2 V2. So here, so N1 is equal to normality of more salt. So we should find it. So V1 is equal to volume of more salt. So that is a 10 ml. And V2 is equal to, so normality of potassium dichromate solution. So that is the 0.1 normality. And V2 is equal to volume of potassium dichromate. So that is the burette reading. So N1 is equal to normality of more salt is equal to N2 V2 by V1. So N2 is equal to normality of potassium dichromate. So that is the 0.1 normality into, so V2 is equal to volume of potassium dichromate. So that is the burette reading by, so V1 is equal to volume of more salt solution. So that is the 10 ml. So both 10 get cancelled. So we should get the normality of more salt is 0.1 N. So now, so we should calculate the strength or amount. So the amount of ferrous ion present in given sample solution. So that is the normality of more salt into equivalent weight of ferrous ion. So the normality of more salt is already, so we are done. So that is a 0.1 normality into, so the equivalent weight of iron is 56. So we should get the, so 5.6 grams per liter. So this is the final results. Okay, now final amount we should get. So the final result is, so the amount of ferrous ion in given sample solution, so that is equal to, so 5.6 gram per liter. Okay students, so this is the finally, so we should get the, so the amount of ferrous ion is equal to 5.6 grams per liter. So this is our final result. So we are not just about the providing quality education, and we believe in the all round developments. Okay students. So okay, thank you.